we will use Laplace transform to solve this system of equation. This is going to be a long problem, so that's why I write on the solution beforehand. All right, so first we have a system of equation. So the first thing we do is we transform, use Laplace transform to transform this equation to a function of s, and that's what we have here. That's where we use Laplace transform, and we have those functions. And then we will use elimination method. What we do here is try to eliminate y and then solve for x. Eliminate y on the top equation, we will multiply by s plus 2. And the bottom equation, we will multiply by 2. With that, the coefficient of y of s will be the same. So when we combine them, we eliminate y, and we have a function equation of x only. And then, so when we have the function of s, and then we isolate it and try to factor x of s out, and when we solve for it, we have this equation for x of s. So that is a fraction, and we have to do the partial fraction, and the partial fraction is in the black in here. As you see, combine like terms and then partial fraction. I'm going to use the calculator and do the reduced row echelon form to solve that system of equation, where we do find the coefficient, and the coefficient will be a, b, c, d will be in this form here, and so we have those coefficients, and with that coefficient we have x of s will be in this form. In that form, and then we rewrite that because we're going to use the inverse transform back into the function. So we're going to keep especially the function in this form. So when we write the 4/5 s over s squared plus 1, so that when we transform back, it will be cosine of t. The same thing here. So that's the first one over s squared plus 1. That's easy. The next we have s squared minus 2s plus 5. So let me write that here. We do have s squared minus 2s plus 5. That is equal to s minus 1 square. I just simply do the completeness square here. S squared minus 2s plus 1 plus 4 will be s minus 1 square plus 2 square. The key here is we have to have a square, s minus 1 square. Right. Because of s minus 1 square here, we try to manufacture the s minus 1 here. So that's why we have to add the minus 1 here, so that we will have the same as s minus 1 at the bottom. Now if we minus 1 inside the parentheses, multiply with the negative 4/5, negative 1 times negative 4/5 is plus 4/5. If we plus 4/5, we have to minus 4/5 to keep things balanced. And then we plus the 3/2 there. It's still the same. Right, then we do the inverse transform. Like I said, the first one is cosine of t. That easy. That one easy. Now we have the negative 4/5 s. This transform give us back to this. That should be easy. Now, one thing of note, the inverse transform, we cannot just have 1 on the top. We have to multiply by 2 here, because that 2 have to be the same as that 2 here. So if we multiply by 2, we have to divide by 2. And that's why we have 7 over 20 instead of the 7/10 as the equation above. And once we have x of t, we will go back and solve for y. We use substitution. We look at the original problem. look like we're going to use this equation, because that one y only appear once. On this equation we have y prime and 2y. That will be difficult to solve for y. So since we use that equation, we write that out and we solve for y. So y will be 2x minus 1/2 x prime plus 1/2 sine t. And then we just substitute in. We have 2 times the function, so that's 2 times x of t, and then negative 1/2. I will use, notice that when we take derivative of x, if we take derivative of this term, we have to use the product rule, and this term have to do the product rule. And finally, don't forget that we also have the plus 1/2 sine t here from here. Right. Now we put everything together. Now we just combine like terms. Notice that we only have sine t, cosine t, e to the t cosine 2t, and e to the t sine 2t. Right. So first I'm looking for everything with cosine of t. Everything with cosine of t, we have 4/5. Don't forget we have multiplied by 2 in front of it, and then 1/10. And that's why we have this coefficient. 2 times 4/5 minus 1/2 plus 1/2 times 1/10. Now we go to sine t. I use 2 underline here. For sine t, we have 1/10. Of course, that we have to multiply by 2. And then we have 4/5 sine t here, and that have to multiply by 1/2 in front. And don't forget we also have the 1/2 sine t here. And similarly, now for e to the cosine 2t, we have negative 4/5 here, multiplied by 2. And we have another negative 4/5 multiplied by negative 1/2, and 7/10 multiplied by negative 1/2. So that's what we have here. And the remaining that is not underlined is come from the term e to the t sine 2t. So I just 2 underline here. So that that term multiplied by 2, that term multiplied by negative 1/2, and this multiplied by negative 1/2. And that's what we have here. Do all the fraction in the bracket. We should have y of t equal to what we have at the end. So that is how we use the Laplace transform to solve a system of equations.